Hi, third graders. Today we're going to be working in lesson 4, which is found on page 159 of your science text. You're going to need a pencil and a highlighter. Let's go ahead and get started. Today we're going to be learning about what are the states of matter, okay? And to get us started thinking about that, I want you to go ahead and answer this question here. If we look at this photograph, we see a girl with a popsicle. How does heating this frozen treat affect it? Think about what would happen when this popsicle gets warm. Go ahead and write a sentence right there to tell us what's going to happen when that frozen treat gets heated up. What's the state? What a party! You can eat a piece of solid cake, drink a cold liquid, or play with a gas-filled balloon. As we read these 2 pages, we're going to draw circles around the names of the 3 states of matter that are being compared. So we're going to listen for those 3 states of matter. There are 3 common states of matter. They are solid, liquid, and gas. Water can be found in all 3 states. A solid is matter that takes up a definite amount of space. Go ahead and circle the word solid and then underline that definition. A solid also has a definite shape. Your science book is a solid. Ice is also a solid. Go ahead and circle those examples of a solid. A liquid is matter that also takes up a definite amount of space, but it does not have a definite shape. Underline that definition and circle the word liquid. Liquids take the shape of their containers. Drinking water is a liquid. A gas is matter that does not take up a definite amount of space and does not have a definite shape. So circle the word gas and underline that definition. The air around you is a gas. And circle the word air. Okay, so now it's your turn. You're going to be looking at the items at this party. Curtains, the ribbon, ice cubes, orange drink, plastic, bubbles, and air in the balloon. And you are going to identify the solids, liquids, and gases in the picture by writing S for solid, L for liquid, or G for gas in each box. So go ahead and pause the video and label each one of these objects with an S for solid, L for liquid, or G for gas. Cool. It's freezing. When matter cools, it loses energy. How does cooling affect water? As you read these 2 pages, draw circles around the clue words that signal a cause and effect relationship. So we're looking for what happens and the reason why. Cause and effect. All the pictures show water at a temperature lower than 0 degrees Celsius or 32 degrees Fahrenheit. How do we know this? If liquid water cools to that temperature, it freezes. That word if tells us that that's a cause and effect. If water cools, then it freezes. Below that temperature, water exists as a solid, ice. Freezing is the change of state from a liquid to a solid. Go ahead and underline that. Freezing is what we call it when liquid turns from liquid to solid. Okay, so now let's look at these photographs down here. Okay. It says that all the pictures here show water at a temperature lower than 0 degrees. So what would happen to this igloo? How would it be different if its temperature was 10 degrees Celsius? So if it started getting warmer, what would happen to this igloo? Go ahead and write a short sentence about what would happen. And then this photograph says, how can you tell that the temperature of the snow is below 0 degrees? Think about what you know about snow and what we read about up here. And how can you tell that the temperature of snow is below 0 degrees? Let's look at this. Hail is water that falls to earth as small balls of ice. This snowball holds together because the water in it is frozen into a solid. That word because tells us cause and effect. This girl can skate on ice because ice is a solid. Go ahead and circle that word because as well. All right, let's look at this story problem here. It says, the temperature of a puddle of water is 10 degrees Celsius. The water cools by 2 degrees every hour. In how many hours will the puddle of water begin to freeze? Explain how you got your answer. So think about the temperature, 10 degrees, and then how much is it going to go down until it freezes? And if it cools by 2 degrees every hour, go ahead and think about how we would solve that problem and show your work and write down how you got your answer. Just add heat. When matter is heated, it gains energy. Go ahead and underline that. How can heating affect water? What happens to an ice cube after you take it from the freezer? As it warms, it begins to melt. Melting is the change of state from a solid to a liquid. Go ahead and underline that. Ice melts at the same temperature that water freezes, 0 degrees Celsius or 32 degrees Fahrenheit. Melting is the opposite of freezing. Go ahead and underline that as well. If we look at these captions here, it says water is a liquid between the temperatures of 0 degrees Celsius and 100 degrees Celsius. We know that at 0 degrees, water freezes, and at 100 degrees, it boils. If the sun heats this ice sculpture enough, it will begin to melt. If you heat a pot of water on the stove, the temperature of the water increases until it reaches 100 degrees Celsius or 212 degrees Fahrenheit. At 100 degrees Celsius, water boils or changes rapidly to a gas called water vapor. You can't see the water vapor, it's invisible. Go ahead and underline that important information. Okay, so now we're going to look down here at this activity. It says, what's the temperature? Draw a line from each thermometer to the picture that shows the state of water indicated by the temperature on the thermometer. So we see water coming out of a garden hose. We see an ice cube, and we see boiling water. So think about what we just learned about and the states of each of these, solid, liquid, gas, and then draw a line to match the temperature on the thermometer. Now you see it. Liquid water can change to a gas without boiling. Look at the drawings of a puddle. What changes do you see? As you read these 2 pages, draw a line under each main idea. Liquid water does not have to boil to become a gas. When you sweat on a hot day, the water on your skin disappears. The liquid water turns into a gas. This is called evaporation. Water can evaporate from other places such as a puddle. Okay, and if we think about this paragraph and what this paragraph is talking about, the main idea is that liquid water doesn't have to boil to become a gas. So go ahead and underline the main idea. And then also go ahead and underline the definition of evaporation. Liquid water turns into a gas. Let's look at this illustration down here. It says the sun's heat makes the water in the puddle change to water vapor, which goes into the air. The puddle gets smaller as the water disappears. Most of the liquid water has changed to gas. A gas can change back to a liquid. This is called condensation. Water vapor condenses as it cools and loses energy. Water vapor in the air condenses on a cold car window. The outside of a cold soft drink can become wet on a hot day. The grass on a cool morning may have dew on it. These are all condensation. Okay, so if we look back in this text, the text was all about condensation. Water vapor condenses as it cools and loses energy. So underline the main idea and also underline the definition of condensation. A gas can change back to a liquid. This is called condensation. Okay, so let's look at this photograph here. We see a girl drawing on a window. I'm sure you've all done that before. It says, what happened to water vapor in this girl's warm breath as she breathed on the cold window? So write a sentence about what happened to the water vapor in her breath as she breathed.